ExoMars' journey began in March at the Baikonur Cosmodrome in Kazakhstan. But for the scientists and engineers who helped make it happen, this joint European and Russian mission has been years in the making to produce the trace gas orbiter, the Schiaparelli lander, which is primarily a technology demonstrator, and their onboard instruments. Like the Cosmodrome itself, ExoMars is also hoping to make history by helping to solve the mystery of why there is methane on the red planet. But first, there are 500 million kilometres for the spacecraft to travel between the launch and its final destination.
We run all the spacecraft tests to make sure that we have the spacecraft fully under control. And then the weeks after, we will start testing one after the other, the instruments, all functions of the spacecraft, the big antenna to communicate to Earth. Everything that can be tested will be done during that phase. And then it just drifts away up to the point that we do the final correction and inject to Mars.
Since the launch, the spacecraft has sent back its first test image on its way to Mars from the orbiter's high-resolution camera. Though not designed to look at stars, this randomly selected image shows that the camera is working well. On arrival at Mars, the orbiter and lander will separate. Spectrometers on the orbiter will take measurements of the Martian atmosphere. One of 3 in the Atmospheric Chemistry Suite, or ACS, was developed in Russia.
Our instrument is devoted to the measurement of trace gases by measuring the solar radiation passing through the atmosphere of the red planet.
The location of where these gases are emerging from will be compared with the images taken by ExoMars' high-resolution colour and stereo surface imaging system, CASIS.
For example, if methane is there in abundance and you see it locally coming from a particular place, you'd like to know whether it's got a volcanic origin, whether it might be old gases that have been trapped in ice that's then released due to sublimation processes.
Methane is also released by microbes, which means potential past or present life. But not everyone is convinced by this possible origin.
It doesn't have to be biology. And it's important to recognise here that I'm a little bit of a skeptic. You know, I don't go for this life business. I try to keep the other guys honest.
But before the science and the excitement begins, ExoMars needs to continue on its long journey. And in July, a major course correction will take place to line up the spacecraft for its arrival at Mars on October the 19th.